Hello guys, today I'm going to be doing a chemistry past paper for the board AQA. So it's a Science A category, Unit Chemistry C1. It's a Monday, 10 June 2013 paper. So it has the code CH1HP paper. So what are the instructions here? Okay, you have to have a ruler, you must have a chemistry data sheet, and mainly I think it's a periodic table, and also some documents that are given. You may use a calculator, use black ink. Okay, so anything important? Okay, the maximum mark is 60. Okay, you must use good English, organize information clearly, and use specialist vocabulary where appropriate. In calculations, show how you clearly worked out your answer. Okay, so let's start the paper with the first question. It is: aluminium has many uses. An aluminium atom has 13 electrons. Draw an electronic structure of an aluminium atom. So now, in order to draw this electronic structure, you have to know what aluminium represents, right? We have to know the atomic structure for aluminium. So since aluminium is in group 3, we know that its atomic structure is 13, right? So it's given here. So aluminium's atomic structure is 13. Remember, an atom's mass number is always greater than an atom's atomic number. So 13, we're going to split this into the first shell can consist of only 2 electrons orbiting. The second shell can consist of about 8 electrons, I think. Third shell consists of 8 electrons, but in this case 2 plus 8 is 10, and 13 subtract 13, you will get 3. Okay, so in the first shell you just put a cross. You can put dots across this, it doesn't matter. So I'm gonna put a cross there. So 2 electrons, 8 electrons orbiting the shell. So how many there are? 1, 2, 3, 4, 5, 6, 7, 8, and 3 orbiting the sides. So you can just leave it like this. I mean, it doesn't matter how you represent it, as long as you represent this. Name the 2 subatomic particles in the nucleus of an aluminium atom. So now, for an aluminum atom, we have to know that it's a proton as well as a neutron, right? So these are the 2 subatomic particles. Remember, this is very specific, so it has to be proton and neutron. Next one, why is there no overall charge on an aluminum atom? So the number of protons is always equal to the number of electrons. So you have to write that. The number of protons is always equal to the number of electrons in an atom, right? That's why there is no overall electric charge, because the number of protons is equal to the number of electrons. Or you could also mention is that the positive and negative charges, they eventually cancel out each other, because protons are positive while electrons are negative, right? So, or you could also mention that there are same amounts of protons and electrons in the atom. Okay, next question is that rail tracks are made from steel. Molten iron is used to weld rail tracks. The reaction of aluminum with iron oxide is used to produce molten iron. Balance equation for the reaction. So what I like to do is to use the left hand side as well as the right hand side. So on the left hand side of the equation we have aluminium, we have iron, and we have oxygen. So okay, so we have, okay, so actually we can just scratch that idea out, but I'm basically comparing how many aluminum atoms out there. So we have 2 iron, we have 3 oxygen, okay. How many iron? We have 2 aluminum, we have 3 oxygen on the right hand side, okay, on the product side. So we're supposed to get 2 iron on the right, so we have 2 iron on the right. We're supposed to have 2 aluminum on the left. So indirectly you're saying you have 2 aluminum on the left and 2 aluminum on the product side. Okay, alright. So why does aluminum react with iron oxide? You can say that aluminum in the reactivity series, aluminum is always reactive, right? It's always reactive. It's always reactive, or you could just mention it's more reactive. It's more reactive than iron, right? It's more reactive than iron, and you can say that iron, you can say like aluminum displaces the iron, and or you could mention that aluminium is higher in the reactivity series than iron, and hence, since it's more reactive than iron, it displaces iron. That's why it's able to react with iron oxide. Now, metals are extracted from their ores. Many copper ores contain only about 2% of copper compounds. So, copper is now extracted from ores containing a low percentage of copper compounds. Now, so just two reasons why. So, the first thing is that it's extracted from ores containing a low percentage of copper compounds, right? Now, why is that? Is that because copper is a metal, right? And all metals eventually run out, just like fossil fuels, right? Or there might be places that where copper ores exist are not found yet, right? Or there are not much places for copper to be found. So you can say another reason is why, because due to this, copper metal, right? The copper metal is in demand, due to copper ores running out, okay? Then there's, like, you can mention that copper is also expensive because it's a metal, right? Because it's more, copper is expensive, so that's what you can mention. Now, chalcocite, an ore of copper, contains copper sulfide. Flow diagram shows how copper metal is extracted from chalcocite. What's this called? Oh, sorry, it's chalcocite. Chalcocite. Okay, sorry guys. Okay, so we have a diagram there. It's a pretty nice diagram. Now, so just one reason why it's difficult to dispose of the waste rock. Now we have there's lumps of ores and there's a waste rock. Why is it difficult, right? It's maybe you can say that the waste rock, I've seen in many marking schemes they say space. Space is one thing that you can mention there. So you can say that space rock takes a lot of space, right? So it takes up a lot of space. Or you can mention that there are large amounts of rock to dispose as waste. Okay, so that's why it is difficult to dispose of waste rock, due to it taking a lot of space. So that means maybe you only need a lot of trucks in order to take the waste rock out, or throw it in areas where maybe you could say it contains like toxic compounds, right? So the main thing is space here, and maybe the toxic levels, I think, of the rock, but mainly it's a space. It takes up a lot of space. Now, the reaction of furnace could cause an environmental pollution. Explain how. So looking at the diagram, you have to understand how this can cause environmental pollution, right? So you can see that copper sulfide, right? In copper sulfide, it reacts with oxygen and it can produce a waste gas. Now, this is an important key point, guys. You have to focus here on why it can cause an environmental pollution. So mostly air pollution is caused, and the mention is waste gas. So what happens when copper sulfide reacts with oxygen? It indirectly falls under the category of it producing sulfur dioxide that indirectly causes acid rain eventually. So this is the mention you can mention. See, the diagram shows everything that you need. So you could say that the copper sulfide, right? It reacts with the oxygen, to form the waste gas called sulfur dioxide, right? Sulfur dioxide that eventually causes acid rain. These are the main points that you need to write down. Is that copper sulfide reacting with oxygen will produce sulfur dioxide, and this eventually will lead to acid rain, right? Okay, so let's move on to the next question. Is that the extraction of pure copper is very expensive. Explain why. There are instances where the marking scheme allows the sentence like large amounts of electricity needed. So I feel we can mention that large amounts of electricity needed. So we'll just mention that point, large amounts of electricity needed, because most of the things needed to be extracted involve electricity. Or you could say that there are large amounts of fuels that need to be used for the furnace and electrolysis. The process of electrolysis is pretty expensive, right? That's why extraction of copper is expensive. The extraction, maybe you can also mention that it has many stages. Or you could say that large amounts of copper have to be mined, like large amounts of ore, or the material that is in this case it's copper. It has to be mined. Okay, so let's just stick with large amounts of electricity needed, okay, to extract copper, pure copper. Pure copper is produced by electrolysis of copper sulfate solution. Which electrodes do the copper ions move towards? So which electrode do they move towards, right? So we need to understand which electrode. Okay, we need to understand that copper ions, they're positive, okay? So since, like you can mention that since copper ions are positive, since copper ions are positive or positively charged, right? You can say are positively charged, right? Positively charged, they move towards a cathode. They are attracted to the negative electron. In this case, it's called a cathode. So to the negative electron called cathode. Okay, right. You can say that opposite charges, and usually I've seen this as well. The sentence opposite charges attract. This can also work if you want to, but for 2 marks, you have to mention what is the charge of copper ions and where they're moving, why they're moving. So because copper ions are positively charged, they are attracted to the negative charges, to the negative electrodes, okay? So the opposite charges, they react with each other. Large areas of land are contaminated with copper compounds. Phytomining can be used to remove these copper compounds from the land. What is the use of phytomining, to remove copper compounds from the land? Okay, phytomining, whenever you hear this word, remember something related to the word plants, okay? It's just growing plants. That's it. You don't need to write anything else. You just say what is used in phytomining to remove copper compounds from the land. It's just growing plants. That's it. So crude oil is a mixture of many different chemical compounds. Fuels such as petrol, gasoline can be produced from crude oil. Now the fuels react with oxygen to release energy. Name this type of reaction that releases energy from a fuel. Now you have to remember that in this case, whatever is releasing energy is always exothermic, right? It's exo. It's not endo. It's exothermic. Endothermic is where energy is being absorbed from the surroundings, and exothermic reactions are where the energy is being released. So in this case, you could also mention burning or oxidation as well as redox, but I'm going to stick with exothermic. Fuels react with oxygen to produce carbon dioxide. The reaction of a fuel with oxygen can produce a different oxide of carbon. Name this different oxide of carbon and explain why it's produced. So fuels react with oxygen. Okay, we know that carbon dioxide is produced, right? So we have to name this different oxide of carbon. Okay. So we know that another way of carbon could be carbon monoxide. Carbon monoxide can also be produced in a blast furnace, right? Oh no, not a blast furnace. This is crude oil. Okay. So you can say that carbon monoxide is being produced as well. Carbon monoxide is produced due to an incomplete combustion. That's it. Due to an incomplete combustion, right? So carbon monoxide is being produced, right? Because there's an incomplete combustion of the fuel. So that's 1 mark where you can get. So you can get 1 mark by mentioning carbon monoxide is being produced, or just the word carbon monoxide, and you can get the other mark because by writing the reason that there is an incomplete partial combustion of the fuel. Okay, now most of the compounds in crude oil are hydrocarbons. Hydrocarbons with the smallest molecules are volatile. So they show us the diagram. Okay, that's pretty good. Now remember, you have to use good English. That means your sentence structuring has to be right. Okay, you have to use right grammar, right sentence structure. So don't write like small stuff. So describe and explain how petrol is separated from a mixture of hydrocarbons in crude oil. Use the diagram. Okay, so we have to use the diagram. So what we have here is petrol, bitumen, crude oil, gases. All right. Now, and your knowledge to answer this question. Okay, so in order to score these, how many marks is this? In order to score these pure 6 marks, 5, 6 marks, we have to create a reasonable explanation of how petrol is, or the fractions are, how are they separated from crude oil using evaporating and condensing. Okay, these are the two methods, right? Okay, so we have to mention some points. just going to mention that we have to say that hydrocarbons, we can say that the first point could be that hydrocarbons, right, they evaporate as gases. They evaporate as gases, right? No, they don't. Yeah, they evaporate as gases, and they form as well as vapors, right? Now, this is similar to, like, I think fractional distillation. I'm not sure, where we boil certain liquids at certain temperatures to get the liquid at the end in condenser, I think, but it has a similar concept of fractional distillation. So we have when some of the carbons, right, when some of the hydrocarbons, or you can mention the fractions in the hydrocarbons. Fractions are just these portions, right? Petrol is a fraction. So when some of the hydrocarbons cool to their boiling point, they condense, right? They condense. And the hydrocarbons which have low boiling points, you can mention that, which have low boiling points, right? They collect near the top of the fractionating column. Yeah, it's similar to fractional distillation. Fractionating column. Right, okay, and accept the converse as well. So while the high boiling points, right, I'm just going to mention that so quickly, they collect near the bottom. Okay, they collect near the bottom of the fractionating column. Then you can say that the process, okay, because it's similar to fractional distillation, we're just going to mention it's fractional distillation, right? Okay, it's fractional distillation, and some of these hydrocarbons, like I said, they condense to form liquids, right? Remain as liquids. So the liquids, right? The liquids flow to the bottom of the fractionating column, and vapors and gases start to rise. Vapors or gases rise in this column. Alright. Okay. So what we need to understand are these points. Okay, you can mention more than 6 points, but just to remain safe, yeah, mention more than 6 points. Okay. So you can mention that some of the hydrocarbons remain as vapors and they condense. You can mention that the gases rise up out of the top of the fractionating column. And the fractionating column, you can also mention this, is that the fractionating column, right? The fractionating column is cool at the top. Whereas it's hot at the bottom. Now this is mainly due to it's hot at the bottom. Right, now why is this? Why is it cool at the top but hot at the bottom? So the main reason is because the high boiling points, that is the hydrocarbons that have high boiling points, are at the bottom, right? They're at the bottom of the fractionating column, making this really hot. Whereas the hydrocarbons which have a low boiling point, they're on the top of the fractionating column because they're cool, right? So they have low boiling points, right? So that's some 6 marks you can mention. There you can put some points and pointers there, but you can mention also the heating, the crude oil mixture of hydrocarbons is heated about maximum, I think, like 350 degrees Celsius. Okay, now give one advantage and one disadvantage of recycling the materials from this type of ballpoint pen. Okay, nickel alloy coin, clear outer case, cap and stopper, ink, stainless steel ball. Okay, we have to understand this to give one advantage and one disadvantage. Right. from this ballpoint pen is that you can mention that it conserves resources, okay, conserves resources, and less energy is being used. See, again, we're using the terminology energy. Less energy is being used, or less energy, instead of electricity, we're just mentioning that the less electricity is being used for producing these materials. 2 marks, okay? You just mentioned conserves resources and less energy being used. Now, alloys are used to make the ballpoint pen. Give 2 reasons why the alloys are used in the ballpoint pen. Now, alloys, you have to remember the main properties of alloys. Alloys are strong, okay? Alloys are strong and durable, right? Strong and durable. They're really hard, okay? So, and they're also resistant. So these alloys, right? These alloys are resistant to corrosion. They're resistant to corrosion. Okay, all right. So since the alloys are very strong and durable, these alloys they're also resistant to corrosion. So that means making them unreactive, so they do not rust. Okay, that's one mark for saying hard, strong, and durable, and another mark for saying resistant to corrosion. They do not rust. All right. Next question, we have decane can be used to produce polyethylene. Describe the conditions needed for reaction 1. So the conditions that are needed for reaction 1, right, is that high temperatures need to be used. So the vapors of decane, right, passed over a catalyst, right? So you have to know that the vapors of decane are passed over a catalyst. They're passed over a catalyst, right, and mixed with steam. They're mixed with steam at very high temperatures. Okay, so this is the mentioning by mentioning high temperatures just gets like 1 mark for that. And mentioning catalyst or vapors of decane passed over a catalyst, right? Actually, you have to mention vapors of decane to get 1 mark, and you could mention either like passing over a catalyst or mixing with steam at high temperatures. That could get you either 1 mark. Or individually, you can just say the vapors of decane are mixed with steam at very high temperatures. Now, describe in terms of molecules how polyethylene is produced in reaction 2. So how this is produced in reaction 2. So as you can see, there are many molecules, right? There are many monomers that join or bond together, many monomers. So this is 2 marks. So there are many monomers which are bonded with each other, So there are many monomers which are bonded with each other, right? You can also mention addition polymerization. This is 1 mark score. Or you could just say that the monomers, they form large chains of molecules to get 2 marks. Complete the displayed structure of the product in the equation. So the diagram doesn't seem to be appearing clearly, but we can see that we have to form 1 bond there. It's a 1 single bond with H. Displayed structure formula no, not H, actually it's C6H5, and we have to just complete it by putting some brackets there as well and connect it to display. So we have to display the displayed structure of the product in this equation. Okay, you just change where the end goes. Change the double bond to a single bond. Okay, so ensure that the bonds that they do not extend through the brackets, right? Show 7 bonds and brackets, and the end should be displayed as well for 2 marks. Now the amount of carbon dioxide. Okay, so complete chemical equation by writing the formula of the other product. Okay, so we have the amount of carbon dioxide continues to change because of human activities. Cement, calcium carbonate is heated, fuel mixture is hydrocarbons. Hydrocarbons react with oxygen to produce carbon dioxide. So when hydrocarbons react with oxygen, they also produce water. So you have H2O being produced. And when there's a thermal decomposition reaction, there's always an oxide being produced. So remember, since they have mentioned that calcium carbonate decomposes, we have to we have to have some metal oxide, because you have to remember a metal carbonate always becomes a metal oxide as well as carbon dioxide. Okay, these are the products, metal oxide and carbon dioxide. So in this case, CaO, that's calcium oxide plus carbon dioxide is being produced. Hydrocarbons and calcium carbonate contain locked up carbon dioxide. Now, what is locked up carbon dioxide? This is some new terminology that we have to understand. Is that the carbon dioxide, right? Locked up carbon dioxide, it means that the carbon dioxide from the air formed rocks, right? So the carbon, and we can just mention that the CO2 from the air, carbon dioxide, it formed rocks, mainly sedimentary or fossil fuels, right? They're trapped, but do not mention the word trapped. Okay, this is not part of the marking scheme, but you have to mention that carbon dioxide is 4 million years ago. So the key points that you need to mention here is that the carbon dioxide that's from the air or during the early atmosphere, it formed these sedimentary rocks or fossil fuels. All right, now graph questions. Finally, something to calculate. Graph 1 shows a percentage of carbon dioxide in the atmosphere changed in the last 4,500 million years, right? So use the information from the graph to answer these questions. Describe how the percentage of carbon dioxide has changed in the last 4,500 million years. So 4,500 million years, this is start 0. Okay, as you can see, the percentage of carbon dioxide in the atmosphere increases with an upward trend, right? So you can say that first, as the years go by, 3,000, 4,000, it increases, right? But in the last 4,000 million years, but it's not increasing. Remember, we're going to the time in million years ago. So many people get the perception that it's increasing, but it's actually decreasing backwards, right? At first I thought it was increasing, but actually it decreases rapidly. It decreases rapidly and starts slowing down. Okay? So you have to mention the word rapidly or decreasing rapidly and then start slowing down, okay? Now give 2 reasons why the percentage of carbon dioxide has changed. This can be mainly due to, you can use the Locke theory, or you can accept photosynthesis as well. So why it has changed is because it's been used by plants, right, in the process of photosynthesis. Photosynthesis is a process where carbon dioxide is being taken from the atmosphere, used by plants in the process of photosynthesis. Then you can mention that it's locked up in fossil fuels. It's locked up. That, for example, in this question we have seen that what locked up means. It just means that it's just where is that? Sorry guys. It just means, okay, it just means locked up carbon dioxide, okay? So it's being locked in fossil fuels or in sedimentary rocks, just like how we have mentioned. So it's been locked up in rocks, or it's formed as rocks. It's been locked up in rocks, or you can mention it's been locked up in fossil fuels, or they're formed as fossil fuels, okay? So there you go, 2 marks, they're all related. Now, graph 2 shows how the percentage of carbon dioxide in the atmosphere changed in the last 250 years. Should we be concerned about this change in the percentage of carbon dioxide? Explain your answer. Okay, this is more like an opinion based. So I think yes, due to global warming, due to climate change, we should be concerned about the change in the percentage of carbon dioxide. Now, I'll give you a reason why. Yes, it's because the percentage of carbon dioxide, that's CO2, the percentage of CO2 in the atmosphere, right, is increasing. So because it's increasing, this can lead to global warming, like how I mentioned. It can lead to global warming, which is not a good thing for the planet. So we need to stop global warming effectively, right? So yes, so the percentage of carbon dioxide, now my reason is yes, because the percentage, as you can see, the graph shows an upward trend, right? So yes, because the percentage of carbon dioxide in the atmosphere increases, right? And the level of global warming, so it causes, which can lead to global warming, right? Which can lead to global warming. Otherwise, if your answer is no, you can mention that the percentage of carbon is low compared to a million years ago. So you can show a comparison between this graph and that graph over there in figure 1, I think graph 1, yeah, you can show the comparison between graph 2 and graph 1. So, but my answer is mainly yes, because the percentage of carbon is increasing, of carbon dioxide is increasing, and which could lead to global warming, and you can also mention climate change if you like. Next question, there were many ideas about how the Earth was formed. Okay, it was formed caused when molten ball of rocks and minerals cooled and wrinkled. Describe the layered structure of the Earth. You should indicate the relative sizes of the layers. So this is, I think, mainly geography. So the Earth consists of crust, not rust. It consists of crust, mantle, and core. These are three layers, main parts. Right? You can just say that crust is relatively thinner. Crust is relatively thinner than the middle core, than the middle mantle, then the mantle and the core. There you go, 2 marks scored by mentioning that the Earth consists of crust, mantle, and cores. Okay, core, only one core. So the crust is thinner than the mantle and the core. Okay, so now at one time scientists thought that the Earth's continents were formed in fixed positions when the molten ball of rock and minerals cooled and wrinkled. In 1912, the scientist Alfred Wegener suggested his idea about how Earth's continents were formed. Now describe Wegener's idea of how the Earth's continents were formed. This is mainly continent based. You have to understand that the continents were joined together. And then drifted apart from each other. So, and then drifted apart from each other. So your main question should be, your main understanding of the Wegener's idea is that the continents were, at first, I think in the early days, they were joined together and then they split apart, or they were moved apart from each other. So they then drifted apart from each other, okay? Now there has been research into fuels for car engines. Wow, okay, this is amazing, interesting stuff. Now mainly it's mostly electric is the future, right? So the flashpoint is lowest temperature fuel vapor ignites in air. The melting point of ethanol is precise, but the other melting points are approximate. Suggest why. So the melting point of ethanol is precise, but the other melting points are approximate. So we can see that ethanol is there, and you have minus 114, but everything else is written about. So we have to understand why. Because ethanol is only made up of, our reason should be because ethanol is made up of one element, ethanol of one molecule, right? So only is made up of one molecule. So you can mention that the molecule is being used here, whereas diesel, petrol, rapeseed oil, they're all mixtures, right? The hydrocarbons and fats, they're mixtures. Whereas you can mention that diesel and the other fuels part from ethanol are mixtures. So now ethanol is produced by fermentation of sugarcane. This is very important. Rapeseed is produced by pressing rapeseeds. Now waste plant material from both processes is used to feed animals, right? Describe how the process of fermentation is done. Now remember, you have to remember the key words. Is that you have to mention that sugar is mixed or dissolved in water. Sugar is mixed in water, and then yeast is added for fermentation to occur. And yeast is added. And the enzymes, enzymes are added. So you can mention that the sugar is mixed in water, and the yeast is added. Now, carbon neutral fuels do not increase the amount of carbon dioxide. Explain why using a biofuel such as ethanol or rapeseeds is thought to be carbon neutral. Now, because they're renewable, right? They're carbon neutral, and that means they have nothing related to putting carbon dioxide back into the atmosphere. So because growing these plants, right, growing the sugarcane and rapeseeds, right, growing the sugarcane's plants, they absorb carbon dioxide, they absorb CO2, and which is released back, it's basically carbon neutral. What goes in goes out, right? So what is burned is back, it's returned. So what is taken is being burnt and given back to the atmosphere. So it's carbon neutral, which is released through burning, right? Which is released through burning. You can mention that it's released through burning, where the biofuel is being burned. Now, when any fuel from the table is used in a car engine, the exhaust gases contain nitrogen oxides. Now, explain why. Why they contain nitrogen oxides is that because N2, right? That's nitrogen and oxygen. Nitrogen and oxygen are in the air, and they react. And they react in the hot engine. They react in the hot engine at high temperatures. This is the reason why the exhaust gases contain nitrogen oxides, because it's due to because of nitrogen and oxygen being abundant in the atmosphere. They react with the hot engine. They react in the hot engine at high temperatures. Now, evaluate replacing petrol with ethanol as fuel for cars. To gain full marks, you must give a justified conclusion. Now, in order to score the full 4 marks, remember, I want you guys to know this, is that you have to always come up with a conclusion. You can say lastly, or you can mention that in conclusion, the words in conclusion, right? So use information from the table and your knowledge to answer this question. Right, we have to use the table. Okay, so what we have to mention here is that the first point that we need to mention: evaluate replacing petrol with ethanol as fuels for cars. So what can we see here? See, we can compare the ethanol, the amount of energy that is released in millijoules. It's pretty less actually, but it needs about like a higher temperature to burn than other fuels, right? So we can mention that ethanol requires a higher temperature to burn than petrol. Ethanol also, as you can compare in the flashpoint column, ethanol has a higher flashpoint than petrol. Okay, ethanol has a higher flashpoint, just mention all the statistics. Flashpoint than petrol. And also you can compare that. One thing is that ethanol, it releases less energy per liter, right? So ethanol also releases less energy than petrol. Okay, and you can mention on the environmental friendly side is that sugar is renewable, whereas crude oil is non-renewable, meaning it will run out eventually, right? So ethanol is made through batch. Ethanol is a slow process. While petrol is made with a fast process. Well, petrol is a continuous process. Okay. Now we give our conclusion. Now, in conclusion, ethanol is a better alternative to use as fuel. Is a better alternative. So I'm mentioning the conclusion is a better alternative than using petrol. We'll give a reason why. Because it is renewable. Right? Because it is renewable and carbon friendly and carbon neutral and is more environmental friendly. It's more environmental friendly. Okay, so because it's carbon neutral and renewable, it doesn't do any damage to the environment because it's carbon neutral. Whatever carbon is being absorbed is being returned back to burning or combustion of the fuel. So it's more renewable and more environmental friendly. So that's the conclusion. Okay, so there are no other questions in the paper. So it looks like we have completed the paper for chemistry. So if you have any other questions, you can ask, comment below. If you enjoyed this video, please like, share, and subscribe. It will help the channel a lot. And if you want me to continue doing more past papers on any other subjects, I would gladly like to help. Whereas I think that's it, right? Bye guys.